Hello everyone. So this is a question from JEE Mains 2026 8th April Shift 2. N-Butane on monochlorination under photochemical condition gives an optically active compound P. P on further chlorination gives dichloro compounds. The number of dichloro compounds obtained ignores stereoisomers. Okay. So the chapters involved is hydrocarbons. So N-Butane is, we know that CH3, CH2, CH2, CH3, right? Monochlorination is the substitution or replacement of a single hydrogen atom in an alkene with a chlorine atom. Okay, so I will write that down. Is substitution or replacement of a single H atom in an alkene with a chlorine atom. To achieve that, to achieve monochlorination, we treat the alkene with chlorine gas, that is Cl2, in presence of UV light or by heating the reaction mixture to 520 to 670 Kelvin range. Okay, to achieve monochlorination, we treat alkene with chlorine gas, that is Cl2, in presence of UV or by heating the reaction mixture to 520 to 670 Kelvin range. Okay, and the process happens via a free radical mechanism to ensure monochlorination, because it is strictly mentioned in the question that we are monochlorinating. Okay, to ensure monochlorination, we take huge excess of alkene relative to the chlorine, which helps to minimize any polychlorination. Okay, very important point. To ensure monochlorination, we take excess of alkane relative to chlorine. Okay, so which helps us to minimize any polychlorination. Polychlorination is substitution of many hydrogen atoms by chlorine atom. We don't want that. Okay, then let's look at the mechanism of this process. So let's illustrate the mechanism by considering the chlorination of n-butane, because the question is talking about n-butane. Okay, in the mechanism, the first step is chain initiation, obviously. So due to the heat that we have used, remember we treated the alkane with UV or by heating. So due to the heat or the UV light, the Cl2 gas absorbs energy and undergoes homolytic fission, producing chlorine free radicals. Very important. Okay, so due to heat oblique UV, Cl2 absorbs energy and undergoes homolytic fission, producing Cl free radicals. Okay, so to show this, we can write chlorine gas or a chlorine molecule. One electron goes here, one electron goes here. So this shows homolytic fission in the presence of 520 to 670 Kelvin, or you can also use UV light and it will result into two chlorine free radicals. Okay, this is the first step. The second step is propagation. Okay, so in propagation, we have the first step. So a chlorine radical, that is this guy, since we have produced chlorine radical, it removes a hydrogen atom from the alkene. And in our case, the alkane is n-butane, to form an alkyl radical and HCl as the product, very important. Okay, a Cl radical removes a hydrogen atom from the alkane. In our case, it is n-butane, to form an alkyl radical, that is R dot. Let's say the general alkane is R, so the alkyl radical will be R dot. Okay, and HCl as the products. Okay, so let's say, in our case, the first case is when, let's draw n-butane, CH3, CH2, CH2, CH3, and let's give them numbers. Okay, 1, 2, 3, 4. So let's say that in the first case, the Cl radical that we produced in the first step attacks C1. Okay, so I will write that down. When Cl radical attacks C1, so in that case, I can write my n-butane as CH3, CH2, 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 and I can separate the hydrogens. Yes. Okay, and Cl radical is attacking it. So what happens is, here this becomes alkyl radical, and this Cl radical combines with the H radical to give us a HCl molecule, and we will be left with CH3, CH2, CH2, CH2 radical, and HCl are the products that we are left with. Okay, so let's say this is radical 1. Okay, so this was the first case. The first case was when the Cl radical attacked our C1. Okay, the second case will be when Cl radical attacks C2. Okay, so I will draw it again. CH3, CH2, CH, H, CH3. Okay, so this is our C2. So this time Cl radical is going to attack this carbon. So obviously this Cl radical will combine with this H radical to form HCl, and then one electron will be given here to form another radical. So let's say we get an alkyl radical CH3, CH2, CH radical, CH3 plus HCl, right? And let's say this is radical number 2. Okay, these are the only two unique radicals possible, because if Cl minus attacks, you must be thinking, no, that there are C3 also, C4 also, right? If it if Cl minus attacks C3, we will get the alkyl radical that we got in the second case. That is, we will get this guy again, this radical again. If Cl radical attacks C3, we'll get this guy again. If Cl minus attacks C4, we will get this radical again. That is the one that we got in first case. Okay, so therefore there are two unique free radicals that we are going to get. This is the first one, and this is the second one. Okay, so this is the first step in propagation. That is, a Cl radical removes a hydrogen atom from the alkene to form R radical. This is the first step. The second step in propagation is the alkyl radical which we got, that is R dot, reacts with another Cl2 molecule to produce monochlorinated product RCl and a new chlorine radical. Okay, alkyl radical, that is R dot, reacts with another Cl2 molecule to produce monochlorinated product RCl and a new chlorine radical. Okay, so let us see how does it happen. So we have got two unique new radicals, remember, alkyl radicals. So let's say the first one that we got was CH3, CH2, CH2, CH2 radical. So this guy combines with a Cl2 molecule. So what's going to happen? Obviously, one electron goes, so we'll get a Cl radical, and this radical combines with another Cl radical to give us the product RCl. So in this case, you will get CH3, CH2, 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 Cl plus chlorine radical. So this is one of the products that we get after monochlorination of n-butane. Okay. The next product will be when the second radical, the second alkyl free radical that we got was CH3, CH2, CH radical, CH3. Okay. So this guy will combine with one Cl molecule. How is this going to happen? Cl will take one electron to form a Cl radical, and this radical will combine with this Cl radical to give us the product RCl. Okay, and our answer will be CH3, CH2, CH, Cl, CH3 plus Cl radical. Okay, so whenever we do the monochlorination of n-butane, we get two products. This is the one product possible, this is the other product possible. Okay, in the question they have said n-butane on monochlorination gives an optically active compound P. Okay, so therefore P must be this guy, because you can see this carbon is a chiral carbon, it has all four different groups attached to it. Therefore this is the optically active product P that the question is talking about. Okay, so this is our P. Okay, and according to the question, we are chlorinating P further to get dichloro compounds. Okay, that is, we are reacting this guy CH3, CH2, CH, Cl, CH3 with more chlorine radicals, free radicals. Okay, so when we do this, when we react it with more chlorine free radicals, there are four possibilities. Okay, four possibilities. The first possibility is when this chlorine combines with this H to form HCl as one of the product, and then we are left with this free radical. Okay, so I will show it separately. CH3, CH2, CH, Cl, CH3 plus Cl. So this combines with this H to form the HCl, and we are left with this radical, that is CH3, CH2, C dot, CH3, Cl. That is, we get this guy as our free radical, and then it combines with another Cl2 molecule to give us the dichloro product. Okay, so this guy will again combine with one more Cl2 to give us the final dichloro product. So this Cl will take away this to form a Cl radical, and this radical will combine with this Cl to ultimately give us the product CH3, CH2, C, Cl, Cl, CH3. So this is product 1. Okay, remember we have four possibilities. The second possibility, let's talk about the second possibility. Remember, we reacted this Cl radical with this H. Okay, in the first possibility, we can also react this Cl radical with one H of this carbon, of the first carbon. Okay, so let's explore that possibility here. So let's say we have CH3, CH2, CH, Cl, CH2, H, and Cl radical. So this guy will combine with this to form HCl, and we'll be left with this particular radical. Okay, so this combines with this H to give us HCl, and then we will end up with CH3, CH2, CH, Cl, CH2 radical, and then this guy combines with another Cl2 molecule to give us the dichloro product. Okay, so this guy will combine with Cl. So this will take an one electron to form a Cl radical, and this radical will combine with this to give us the product 2, that is CH3 CH2 CH Cl CH2 Cl. So this is the second different product that we are getting. Okay, after dichlorination. Cool. Then let's talk about the third possibility. Remember, uh, in the first possibility, we reacted this chlorine free radical with this H of the C2 carbon. In the second possibility, we reacted this with the C1 hydrogen of the C1 carbon. In the third case, I will react this Cl free radical with hydrogen of the C3 carbon. Okay. So I will write it in this fashion: CH3CH H CHCl CH3. So this guy will combine with Cl radical. So Cl radical will combine with this H, and this will result in the formation of HCl, and we will be left with CH3CH radical CHCl CH3. Okay, and then this guy, the radical that we are left with, the alkyl radical, will combine with a molecule of Cl2 to give us the dichloro product. So this will result in a Cl radical, and then this radical and this Cl will combine to give us the third product, that is CH3CHCl CHCl CH3. So this is the third product. Okay, and the fourth possibility is, if you remember, in the first case we reacted Cl radical with hydrogen of C1, second case Cl radical with hydrogen of C2, third case Cl radical with hydrogen of C3, fourth case Cl radical with hydrogen of C4. Okay, so I will write it in this fashion, that is CH2H CH2 CH Cl CH3 combining with a Cl radical. So obviously this guy will combine with this H to form HCl, and we will be left with this particular radical. Okay, so we will have HCl and CH2 radical CH2 CH Cl CH3. Okay, and then this alkyl radical will combine with another chlorine molecule to give us the dichloro product. Okay, so this will combine with Cl. So one Cl will take one electron to form a Cl radical. Then this radical will combine with this Cl to give us the fourth possible product, that is CH2Cl CH2 CHCl CH3. Okay, so this is the fourth product that is possible, the fourth dichloro product. Okay, so this is the first one, first dichloro product. This is the second one, this is the third one, and this is the fourth one, and all four of them are different. And in the question they have said that ignore stereoisomers. Okay, so therefore the answer is going to be 4. The number of different dichloro compounds that we get is 4. Okay, thank you.